Okay, hello, selamat sejahtera. My name is Bartimius. So today I will explain about experiment 4, F4, which is the title is energy losses in pipe and fitting. So the objective of this experiment is to determine the losses in the pipe fitting related to flow rate and to determine the loss coefficient related to velocity head. And the last one is to compare the losses of energy in different configuration of pipe. So we go to the apparatus. So for the apparatus, as you can see, for number 1 is 45-degree elbow, which is in this part. And number 2 is contraction. So this is contraction. Number 3 is enlargement. So this is number 3, enlargement. And number 4, 90-degree elbow. So this is 90-degree elbow. And number 6, 90-degree short bend. So in this part. And number 5, water inlet connection. So this is water inlet connection. And we go to the number 7. So manometer banks. So this is manometer banks. And number 8, gate valve. And number 9, differential pressure gauge. So this is differential pressure gauge. And number 10 is 90-degree elbow 2. So this is the 90-degree elbow. And number 11, the last one is water drain connection. So we go to the procedure. So number 1, place apparatus on bench. Connect inlet pipe to bench supply and outlet pipe into volumetric tank. So in this part. And then number 2, with the bench valve fully closed and the discharge valve fully open, start up the pump supply from hydraulic bench. Number 3, slowly open the bench valve until it is fully open. Number 4, when the flow in the pipe is steady and there is no thread bubble, start to close the bench valve to reduce the flow to the maximum measurable flow rate. Number 5, by using the bleed valve, adjust water level in the manometer board with the maximum reading on manometer with the maximum measurable flow rate. For the note, a lower flow rate will reduce the water level while higher flow rate will increase the water level. So number 6, note reading on manometer and measure the flow rate with volumetric tank. Number 7, repeat the experiment with different flow rate. The flow rate can be adjusted by utilizing the bench flow control valve. Number 8, plot graph differential piezometer head against velocity head for each device and determine the loss coefficient. So we go to the result and analysis. So this is the data for table 2, and we got the calculation for time flow rate. And then I will show you the calculation, the sample calculation for one row from this top at time 21.5. And also for table 3, we need to do calculation to find out velocity head, 90-degree elbow wind, 45-degree elbow, sudden enlargement, sudden contraction, short bend, and the last one, 90-degree elbow 2. So we will go to the graph because we need to plot a graph. So this is the graph that I have made, but I will show you how I do this graph. First of all, we go to the insert and then go to chart, scatter, and then we select data, add, and series X value we choose velocity head, and for the y axis is 90-degree elbow, and then so this is the result, and then the title is velocity head, versus 90-degree elbow 1. Like this, and after we do that, we need to do the title for y-axis and x-axis too, and we will get the graph like this. I will enlarge it. So we will get answer like this for the graph of velocity head versus 90-degree elbow 1. So next, this is all the graph. I'm sorry. As you can see, so this is velocity head versus 45-degree elbow, and this is velocity head versus sudden enlargement, and this velocity head versus sudden contraction, and this is velocity head versus short bend, and the last one velocity head versus 90-degree elbow 2. So this is all the graph that we need to plot for this experiment, and as you can see, all graph is proportional to each other. Velocity head is proportional with 90-degree elbow 1, 45-degree elbow, sudden enlargement, sudden contraction, short bend, and 90-degree elbow 2.
So this is the calculation part. First of all, we go to the equation of volume flow rate. Volume flow rate is Q. So the unit is meter cube per second. So first of all, we need to convert a liter to cubic meter. So 4 liter gonna be 0.04 meter cube. So for the time is 21 second 0.5. So as you know, the equation of volume flow rate is equal to V over T, which is volume over time. So 0.004 cubic meter divided by 21.5, and we will get answer 0.000189 meter cube per second. So next we go to the velocity. So the unit for velocity is meter per second, and the formula is 4q over pi d square. So the diameter is 17 millimeter, so we convert it to meter, and it's gonna be 0.017 meter. So we fill up the equation with the value of volume flow rate, which is Q, so 0.00189, and then over pi time diameter 0.017 square. So the answer will be 0.832 meter per second. So next we will find the value of head velocity. So the unit is meter h2o. So the formula is v square over 2 times gravity. So we fill up the value of velocity over 2 times gravity, which is 9.81, and we will get value of 0.0853, and don't forget the unit. So next we go to the 90-degree bow 1. So the formula is delta H equal to H1 minus H2, and we can get this value in the table 1. So first of all the value we need to convert into millimeter. So 0.354 minus 0.323, and we will get answer 0.031. And for the 45 degree elbow is also delta has same formula but a different value, because for 45 elbow we need to use H3 minus H4, so 0.29 minus 0.274, and we will get answer 0.015. So next we go to the sudden enlargement. and sudden enlargement is equal to H5 minus H6, and the value is 0.252 minus 0.237, and the answer will be 0.015. And for the contraction is delta H equal to H7 minus HA, and the answer is 0.195 minus 0.178, and the answer is 0.017. So the last one is 90 degree elbow 2, and we use to delta H equal to H9 minus H10. The answer is 0.227 minus 0.195, and the answer is 0.032. So this is all answer for the calculation.
So for the conclusion of this experiment, the objective of this experiment is achieved. We can determine the losses in the pipe fitting related to the flow rate, and we can determine the loss coefficient related to velocity, head, and the last one, we can compare the losses of energy in different configuration of the pipe. Next, by doing this experiment, we are able to know the flow process of this procedure until the first step to the last step, which is step 8, until we plot the graph. And the last, other than that, from this experiment we can learn how important of the energy, how important that we know to know the energy losses in pipe and fitting, because there's many application that need to use a piping system, and we can know how much the energy losses in that pipe. So furthermore, from this experiment, we also know how to get the answer by doing a sample calculation, and from this we can know the calculation is important, and we need to learn it to fill up the table and to solve the problem about piping system. And then lastly, for this experiment, I also know the importance of safety procedure for this experiment, because we cannot ignore the safety by in doing any experiment. So this is all the conclusion that I got from this experiment. So for the safety procedure, there are 12 steps that we need to know and we need to follow the instruction of this safety procedure. The first procedure, number 1, is student must arrive at each season on time with proper dress code, lab coat and shoes. Slippers are not allowed. And number 2, students are not allowed to enter the laboratory without permission from the lecturer or technician. Working alone or unsupervised in laboratory is forbidden. Number 3, bags are not allowed in the laboratory. Number 4, students are not allowed to eat, drink or smoke while working in the laboratory and are not allowed to run the experiment with their hand wet. Number 5, Students are not allowed to run the experiment when they are sleepy or under medication. Number 6. Read the instruction carefully and follow the laboratory procedures. Do not touch anything that you are not completely familiar with. Number 7. Ensure that your circuit and equipment connection are correct before turning on the power supply. Number 8. Ensure that the switch are off, the plug are unplugged, and the working area is clean before you leave the laboratory. Number 9. Place the equipment, tools, and components back to their original place after the experiment. Number 10. Notify your instructor immediately if there is an accident. Number 11. Keep the lab clean and neat before and after conducting an experiment. And number 12. Lastly, keep the work area clear of all materials except those needed for your works. Thank you so much.